I'm Anil Kumar. Welcome to my series on exam review. We'll take up limits in this particular video. I very carefully selected 6 questions. Last minute changes can be reflected on this first page itself. I would like you to pause the video, copy these questions, answer them, and then look into my suggestions. Question number 1 relates to evaluating limits for different kinds of functions. Question number 2 is missing. I've added it at the end. We'll have a word problem where we are going to use difference quotient method to find a point where velocity is 0. Question number 3 is using properties of limits. I'd like you to copy this one, try it out. Question number 4 is on understanding limits basically. You need to evaluate this limit and also interpret the limit and explain its significance. It's a communication question. Question number 5 is probably a very difficult question in this series. You need to find horizontal asymptote for each of the following. So I've kept 2 examples here. Finding horizontal asymptote means you have to find limit when x approaches positive and negative infinity, correct? So for question number 5, let's be very clear. You have to find limit when x approaches positive infinity. Also, you have to find limit when x approaches negative infinity. Both could be different, right? So keep that in mind. Then we'll move forward to question number 6, which is determine the following from the graph of the function. Actually, I will start my solutions from this question itself. Normally, you will expect that as your question number 1 in your test paper. Okay, so let's get ready and solve this review exercise on limits. Question number 6 for me is, the graph is given to us. We need to find limit of this function as x approaches -2, that is -2. We need to find the value of the function f of 1, limit of the function when x approaches 1 from positive side, and limit of the function when x approaches 2 from positive side. Okay, so let me rewrite this. So first, which is part A, is to find limit when x approaches -2 of the function f of x. So this is the function f of x given to you. That is -2, right? So this extreme value is at -2. Here we have 1 and then we have 2, right? So that should help. This point here is 3, right? So 2, 3, and 4. Pause the video, answer the questions, and then look into my suggestions. So A is limit of this function as x approaches -2. B is value of the function at 1, right? Now let's answer A. -2 is right there in the corner. So what is the limit for this? Well, some of you might have answered this as 4, which is a wrong answer. This limit does not exist. The reason is that the function is not defined from the left side of -2, simply because the limit when x approaches -2 from the left side for this function does not exist. Is that okay? From the right side, if I write plus here, the value will be 4. But since both these limits are not same, right, so we can write that the limit x approaches -2 from left side for the function is not equal to the limit when x approaches -2 from the right side. It does not exist. So I hope this concept is absolutely clear. F of 1, so at 1, this is a whole, that is a filled in value, so the value at f of 1 is equal to 1. Limit of the function, let me write down here, limit of the function f of x as x approaches 1 from positive side, that is right. So if you are approaching from the right side, what are you approaching? at, you're approaching here, right? Not this place. So this limit from the right side exists and it is 3, right? So this is equal to 3. Perfect. So this is 3. Now let's answer the next question, which is limit when x approaches 2 from the right side for the given function. So when you are approaching 2 from the right side, you hit the graph where? On this side. Do you see this? And you approach a value of -2. So this is -2, correct? So that is how it should be answered. So I hope the concept is absolutely clear. Let's move on and do question number 1 now. Question number 1 is to evaluate each of the following limits. So we have actually 4 examples. Let's do these 2 first. We have limit when x approaches -1 for x cubed plus 1, x to the power 4 minus 1. So look here. Let's rewrite this question. Limit x approaches -1 for x cubed plus 1 over x to the power of 4 minus 1. Now, if I substitute -1 here, what do I get? Let's check. So if I do -1 cubed plus 1 over -1 to the power of 4 plus 1, I get 0 over 0. Now, this is indeterminate, right? Since it cannot be evaluated, that means we also know that there is a common factor that made this 0 in both numerator and denominator for -1. There is a common factor. To be very precise, the common factor is x plus 1, correct? So the idea is to factor this out, cancel the common factor. Do you understand this strategy? That is the strategy. So we'll actually rewrite this question, factor numerator and denominator. So if you factor numerator, it is a cubed plus b cubed. We get x plus 1 times x squared minus x plus 1. Is it okay? Divided by x to the power of 4 minus 1, which could be written as x squared plus 1 times x squared minus 1, right? Which I could write as x plus 1 times x minus 1. I'm skipping a step here, but I hope it is absolutely clear since you are ready for your final exam. So this is actually x squared minus 1, which I factored. Now you could cancel this common factor, correct? This 0 resulted because of this common factor. You get the idea, right? So once we cancel, we can substitute -1 and evaluate the answer. So -1 squared minus of -1 plus 1 divided by -1 squared plus 1, right? So this is 1. This is also plus 1 plus 1, and here we have 1 plus 1, which is 3 over 2. So this limit is 3 over 2. Is that okay? So this is 3 over 2. So I hope the steps are absolutely clear. Very important. Now let's look into part B. We need to find limit of 1 over square root of x minus 2 when x approaches 2. Now if I substitute 2 here, what do I get? So we need to find limit when x approaches 2. And we are working with this function x minus 2, right? Now if I substitute 2 here, what do I get? So if I substitute 2 here, I get 1 over square root of 2 minus 2, which is 1 over 0. Now this is 1 over 0. We know it does not exist, right? So it does not exist. Remember, no need to rationalize this function, no need to factor. This is 1 over 0. It is not 0 over 0, right? So the answer for this is does not exist. So I hope this concept is absolutely clear. And now let's move forward and do rest of the questions. Now we are going to evaluate limit of these two functions. I hope you understand and appreciate the selection of these questions. It really gives you an insight to finding limits for different functions. Now here we have to find limit for square root of x minus 2 divided by square root of x cube minus 8 when x approaches 4. So if I write 4 here, square root of 4 is 2, so I get 0. And here also if I write 4, I get 4 cube square root, I'll get 8. So it is 0 over 0, indeterminate. So we are going to use one of our strategies, and this time we will use the method of substitution, right? So we are going to substitution method, apply substitution this time. So let us substitute. Which one is smaller? Well, square root x is smaller. So let's substitute square root of x as, let us say, u, correct? In that case, x will be what? X will be u square, right? And this cube will be u cube, right? Okay. Now another important thing here is, when x approaches 4, in that case, u approaches what? Since u is square root of x, which is square root of 4, right? So u approaches square root of 4, which is 2, correct? So that helps us to redefine the function with different variables. So we could rewrite this function as limit u approaches 2, right? Instead of x approaches 4. And we have substituted square root of x as u. So we get u minus 2 in the numerator divided by, here, x cube square root. So it is u cube, correct? U cube minus 8. Does it make sense to you? Right? So that is how it is. So basically, we actually wanted cube of x squared, so which is u cube. Does make more sense? It does, right? Now, you could always expand the denominator using the formula u minus 2, a cube minus b cube formula, right? Let me write down. What is a cube minus b cube equals to? It is a minus b times a square plus ab plus b square. So we are going to use this formula to expand the denominator. We get u minus 2 times u square plus ab means 2u plus 2 square, right? Let's write 2 square, which is 4. Now, u minus 2 and u minus 2 cancel. So we are left with limit u approaches 2 for 1 over u square plus 2u plus 2 square, which is 4, right? This is 2u. So now we can substitute 2 here. So we get 1 over 2 square is 4, 2 times 2 is also 4, and we already have 4 here, and our answer is 1 over 12, right? So the limit of this is indeed equals to 1 over 12, correct? That is how we are going to answer. Now let's do the next function, which involves absolute function, right? Let's see how to find limit when we are working with absolute functions. The equation could be written as limit x approaches 2. You can factor the numerator, x square minus x minus 2, product of minus 2, sum of minus 1, can be written as x minus 2 times x plus 1, right? Now the denominator is absolute value of x minus 2. Now whenever you have absolute value, we have to split this into a piecewise function and then evaluate. You remember what is absolute value of x minus 2 equals to? It is either x minus 2 or negative of x minus 2, depending on x value. If x is greater than, what makes it 0? 2, right? So greater than equal to 2, it is positive value. But if x is less than 2, it is negative of that value. So we will define this limit in two intervals. One when x is less than 2, and the other when x is greater than equal to 2. Now if x is less than 2, the question really becomes limit x approaches 2. Now less than 2 means you are approaching from the left side. So let me write minus here. Does make sense to you, right? So the question now is x minus 2 times x plus 1 divided by, now the absolute function is negative of x minus 2, right? On the right side, we are actually looking forward for the limit of x approaching 2, but from the right side, 2 positive, correct? So we have the function as x minus 1 times x plus 1 divided by x minus 2. Now this cancels, right? Here also this cancels. However, there is a difference. What we get on the left side is limit x approaches 2 from the left side. We get negative of x plus 1, right? This negative. On the right side, we get limit x approaches 2 from the positives for x plus 1. Now if I substitute 2 here, what do I get? Substituting 2, I get negative 3, right? 2 plus 1, which is negative 3. And if I substitute 2 here, what do I get? I get 2 plus 1, which is positive 3. Now these two limits are not equal. Therefore, this limit does not exist. So I hope that is clear, right? So I like you to take a break, try to understand what we have done here, and then we'll move on to question number 2 onwards. Question number 2 is an application question. A toy rocket is launched straight up so that its height s in meters at time t in seconds is given by s of t equals to minus 5t square plus 30t. When is the velocity of this rocket 0? Note, solve using difference quotient method, right? So I do not want you to use derivatives, but solve it using first principle, right? Okay, we are given displacement or the height, right? So height is given to us as minus 5t square plus 30t. Now what is velocity? Velocity is rate of change of height, right? Rate of change of height. So let's say s of t. Is that okay? Which you can find by using difference quotient method. So what is the formula for that? So basically it's a definition of limits, right? So we can say velocity at any time t will be equals to limit at a point which is very close, right? So if say h approaches 0, and let's say the point is a, in that case s of a plus h minus s of a over h, right? That makes sense to you? So that is the difference quotient method which we can use to find the velocity, correct? When we say when the velocity of this rocket is 0, we'll actually equate this to 0 and find the value of a. Is that okay? So a is the time when it is going to be 0. So I hope that makes sense, right? So let's just apply this formula now, and we can write down that the velocity is indeed equals to limit of this function when h approaches 0 for s of a plus h, right? So t will be replaced by a plus h. So we have minus 5 a plus h whole square plus 30 a plus h. So that is a plus h, and then we'll do, well, I should have written here minus s of a, then we'll do minus of s of a, which I'm writing here as minus 5a square, replace t with a, right, plus 30a, right, and all this divided by h. So all this divided by h, let me now make a square bracket here and type 1 over h. Does it make sense to you? Sorry for that mess up, right? Let me rewrite this. So what we have here is limit h approaches 0, and all this is in the numerator we have minus 5 times a plus h whole square. Let me expand this. So we get a square plus 2ah plus h square, right, plus 30h. Let's open this. We got 30a plus 30h. Let's open this bracket also. Minus and minus becomes plus 5a square. This term will be negative 30a. Is that okay? So all this, right, divided by h. Now, there it goes. Is it clear? So that's what it is. Now you'll find that when you do this, some terms will cancel, especially 5a square minus 5a square, this cancels. Is it okay? And also we have 30, I wrote plus 3a, let's see, a plus h, 30, right? So this I wrote wrong. It is 30 times a, right? So 30a. So this 30a cancels with minus 30a, right? Since it is 30 times a, not 3a. Okay, so that's what cancels. What really remains is the terms with h. So all other terms cancel, right? You must have learned this by now. Always that is going to be the scenario. So we can take h common. So we get what we get. We'll open the bracket and take h common. Okay. So we get minus 5 times 2, which is 10 ah. We'll do it in 2 steps. Minus 5h squared, and we have here plus 30h. Is it all? Yep. Divided by h. Is it okay? So now we'll write this as limit h approaches 0. H is common, right? So we say h times minus 10a, and then we have minus 5h, and then we have plus 30 divided by h. Now this is a common factor which can be cancelled, and this is the time when you can really substitute h equals to 0. So we get minus 10a plus 30. And here, since we want the velocity to be 0, right? When will the velocity of the rocket be 0? So we want velocity to be 0. So I'll equate this to 0. Is it okay? And find the value of a. That's the whole idea. So we'll write 0 equals to, when I substitute 0 here, that term becomes 0. So this approaches 0. Is it okay? So we are left with minus 10a and here plus 30. So that gives you 10a equals to 30, and from here you can find what a is, right? So a equals to 30 divided by 10, which is 3. So basically, at t equals to 3, velocity is going to be 0. So we can write down our answer. At t equals to 3 seconds, velocity equals to 0 meters per second. Is that clear? So that is how this question is to be solved. Perfect. So we have used difference quotient method and found that velocity is 0 at t equals to 3. And that also means, this could have more parts to it, right? So part 2 could be find maximum height, things like that, right? So you could find actually maximum height, as this is the turning point, right? So the object goes and falls. This is the time t equals to 3. So if you substitute 3 here, you'll get maximum height at s of 3, right? We have not included this now, but it could be in your test paper. Right? Now, let's move on and do question number 3. Question number 3. If limit of f of x over x when x approaches 0 is 5, and limit of g of x when x approaches 0 exists and is non-zero, then evaluate each limit. So what we are given here? We are given that limit x approaches 0 for f of x over x is equal to 5, right? It is non-zero. And we are also given that the limit x approaches 0 for g of x is not equal to 0, but it exists. Now we have to answer the 2 questions. I'd like you to pause the video, answer these questions, and then look into my suggestions. The first one here is to find limit when x approaches 0 for f of x. Now what should that be? Let us try to understand the given limit. So, f of x over x, the limit exists. If I substitute 0 here, it means what? We get 0 in the denominator, it becomes undefined. Limit exists, that means it is indeterminate. That means since limit of this function f of x over x is 5, it means that f of x has x as a factor. Do you understand? So if x is a factor of f of x, then what should be the limit? Then the limit when x approaches 0 for f of x should be 0. Right? Should be 0. Let me give you an example here, right? So, example, your f of x could be equals to, for example, 5x. The next x will cancel, 5 will be my limit. Do you get an idea? And as such, for 5x, limit exists at x equals to 0. Substituting, you get 0. I hope that's absolutely clear, right? Okay, let's move on to question number 2. Part B. Now here, we need to find limit when x approaches 0 for f of x divided by g of x. Now we know that limit of g of x exists, but it is non-zero, right? So this limit could be equals to limit of f of x when x approaches 0 divided by limit of g of x when x approaches 0. Now here we know that limit of the numerator is 0 and this is something but non-zero. Is it okay? So 0 divided by anything is 0. So we get 0 as our answer. So this limit is 0 and that limit is also 0. So I hope this concept is absolutely clear. We have also used properties of limits while solving this question. So the type of questions which I have selected actually gives you a very good review. Let's move on and do question number 4. Question number 4 is very different from previous 3 examples which we took. Evaluate limit 1 over h within brackets 1 over 2 plus h square minus 1 over 4. And second part is interpret the limit and explain its significance. Okay, so let's first evaluate the limit. So we need to find limit when h approaches 0 for the function which is 1 over h, 1 over 2 plus h whole square minus 1 over 4. So let's take the common denominator. So we can write this as limit h approaches 0, 1 over h. So if I take the common denominator, what do I get? I get 4 times 2 plus h whole square in the denominator, cross multiply, we get 4 minus 2 plus h whole square in the numerator. Clear? Now, we could write this as limit h approaches 0, 1 over h. Let's expand 4 minus. So what we get here within brackets, I'll write down a square plus 2ab, which is 4h plus h square, right? Divided by 4 times 2 plus h whole square. Do not expand denominator ever. Okay, is that clear? Do not expand denominator. Now 4 and 4 will cancel. We'll open the bracket and then we'll see if h could be taken as a common factor, correct? So we have minus 4h plus h squared, so I could take minus h common and I get 4 plus h in my bracket. And here we have 4 times 2 plus h whole square. Now we can cancel h with this h. Does make sense to you, right? So, and substitute h equals to 0 to get the answer. So if I substitute 0, I get minus 4 over 4 times 2 whole square, which is minus 1 over 4, correct? So that is what you get, minus 1 over 4. So that is how you could actually solve this particular question. So I hope that makes sense. Okay. Let's try to understand what this is all about. If you see, the original function f of x seems to be 1 over x squared, right? That is the function we are working with. And when we try to find limit, we are actually finding the limit of this function when x approaches 2, the 2 plus h, right, of the function f of x, which is, or you can say limit when x approaches 2 for 1 over x squared. Do you see that? So that is what you're trying to calculate. So what you've got here is basically, you could interpret this as slope of tangent on the graph of f of x equals to 1 over x squared at x equals to 2, right? So that is what the interpretation is. Is that clear, right? So that is how you are going to interpret. So I hope it is absolutely clear. Let's move on and do question number 5, which is also the last question of the series. I'm Anil Kumar, and we are almost at the end of our exam review on limits. We started with question number 1. These were the questions. And now we are going to work out question number 5. We did question number 2 and 6 in between. I'd like you to actually pause the video, copy these questions, find the horizontal asymptote for both, and then check with my solution. Let's begin. Question number 5. We need to find horizontal asymptote for the function which is f of x equals to x over square root of x squared plus 1. Now when I say horizontal asymptote, basically we want to find limit of this function when x approaches minus infinity. So limit of this function will is x over square root of x squared plus 1. And also we need to find limit of this function as x approaches positive infinity for x over square root of x squared plus 1. Now I've seen that even at this stage, when final exam is due, many students think that both the horizontal asymptotes will have same equations. Purposely, I've taken this example to show you that they don't, right? Okay. And we'll learn few more techniques here. So let's begin with the horizontal asymptote on the left side. So what we will do here is that we will actually factor out x squared from the denominator. So what we have here is x over, so within square root, I'll factor out x squared. I'll get 1 plus 1 over x squared, correct? Within square root. Now if x is very large, then 1 over x squared will be 0, correct? So I could write this as limit x approaches minus infinity for the function being square root of x squared. Why did I do so? Simply because the limit when x approaches infinity or minus infinity or plus infinity for 1 over x squared is 0, right? So when you're dividing 1 by a very large number, whether it is negative or positive infinity, you'll get 0. So this part is 0, right? This is equal to 0. So we're left with 1. So x squared. Now you have x over square root of x squared. What is that? Well, some students think it is x. That is a huge mistake, right? What we get here is x over, this is always positive, so it is not x but absolute value of x. So another thing which you have to remember is square root of x squared is not x, it is absolute value of x. Okay? Now, when I'm saying that x approaches negative infinity, then what is the value of absolute x? That's the next question which you need to answer. Okay, let's highlight. So absolute value of x is equal to what? Either x or minus x. When x is greater than 0, it is x greater than or equal to. However, if x is less than 0, it is negative x. Since we are approaching negative infinity, it should be what? It should be negative x, right? So we get limit x approaches negative infinity. We get x over negative x, which is negative 1. Do you see that? So the horizontal asymptote on the left side is negative 1. Is that clear? Not positive 1. Now let's do the right side. So I hope this concept is clear. Right? Part B is for you to do and apply this concept which we are learning. Let's now do limit when x approaches infinity. So on the right side. So we'll do exactly same steps. We say limit x approaches infinity, factor out x square, right? So we get square root of x square, 1 plus 1 over x square. So now you understand 1 over x square will be 0. So we could write this as limit x approaches infinity, x over square root of x square. Since this is 0, right? Since this approaches 0. And now we are approaching this side, positive side. So I will write this as limit x approaches infinity, x over, first we'll write absolute x, and then we will say this absolute value of x in fact is positive x. So we get 1. So this limit is 1. So what we found is that when you are approaching the right side, then the limit is 1. But when you are approaching on the left side, it is minus 1. So there are two horizontal asymptotes, correct? So we can now clearly write our answer that we have horizontal asymptotes as y equals to minus 1. This is when x approaches negative infinity, and y equals to plus 1. This is when x approaches positive infinity. Is that clear, right? So we get our answer, and that is, right, that is, as x approaches negative infinity, y approaches negative 1. When x approaches positive infinity, y approaches positive 1. So this gives me one horizontal asymptote, which is y equals to minus 1, and that is the other, which is y equals to plus 1. So we have two horizontal asymptotes, right? So I hope this concept is absolutely clear, right? Go through it. So you can pause the video, go through this solution. Once you are done, then you try the next part, which is right there. So we need to find now the horizontal asymptote for the function f of x equals to square root of x square plus 4x minus square root of x square plus x. So I'd like you to pause the video, answer this question, and then look into my suggestions. So we need to find horizontal asymptote for the function. So that is to say, we will find limit when x approaches minus infinity for the function, and also we'll find limit when x approaches positive infinity for the function, right? Now, for such absolute functions, the square root functions, we should rationalize. So the strategy here is to rationalize. So let's rationalize and then find the answer for both. So we can write the function f of x as equal to square root of x square plus 4x minus square root of x square plus x. To rationalize, we'll multiply and divide by its conjugate, which is going to be x square plus 4x plus square root of x square plus x divided by square root of x square plus 4x plus square root of x square plus x. Does make sense. The numerator is going to be difference of squares. So we get x square plus 4x minus x square plus x. Denominator I'll just keep as such, which is square root of x square plus 4x plus square root of x squared plus x. So you can simplify the numerator. X squared minus x squared cancel, and I wrote this a squared minus b, minus b squared. This minus is outside, so we get x squared minus x squared minus x squared is 0, but 4x minus x is 3x, so we get 3x over square root of x squared plus 4x plus square root of x squared plus x. Is that clear? Right? So now we'll actually take x squared common in both these cases. So we could write this as 3x over square root of, so if I take x squared common, what do I get? I get 1 plus 4 over x in the first square root, plus in the second one I get x squared common, I get 1 plus 1 over x. Does make sense to you, right? Now x squared square root is absolute x, which we could factor out. So now I could write this expression as 3x over absolute value of x, and within brackets I get square root of 1 plus 4 over x plus square root of 1 plus 1 over x. Is that clear? So we kind of simplified our expression. Okay. Now what we know here is that absolute value of x is either equals to x or minus x, depending on which domain you are working. Is it okay? So now if we are finding two different limits, that is to say, let's find limit when x approaches minus infinity. In that case, absolute x will be equal to minus x, correct? So let's do that part first. So we'll say limit of this function when x approaches minus infinity, that is the function now, is 3x over, so this becomes negative x, right, times all this, correct? Now since x, let me first write this, 1 plus 4 over x, square root, plus square root of 1 plus 1 over x. Is it okay? Now in this case, x and x cancel, but you get negative sign. So what you get here is limit, we wrote the function. So limit when x approaches minus infinity of minus 3 over, now both these terms approach 0, right? When x is very large, this and this both approach 0. So we have square root of 1 plus square root of 1. So what we get here is minus 3 over 2. So that is your horizontal asymptote. Okay? Now, let's also find the limit of this function when x approaches positive infinity. In that case, this value is going to be positive, right? So what we get here is 3x over x times square root of 1 plus 4 over x plus square root of 1 plus 1 over x. And when x approaches positive infinity, what we get here is these two cancel away, so we get 3 over 2. Correct? Therefore, what are the horizontal asymptotes? We can now write our answer as horizontal asymptotes are when x approaches negative infinity, y approaches negative 3 over 2, and when x approaches positive infinity, y approaches positive 3 over 2. So these are the two horizontal asymptotes. Is it okay? So this equation is y equals to minus 3 over 2 and y equals to plus 3 by 2. Is that clear? So we have two horizontal asymptotes in this example. Now purposely I have taken two examples so that you understand what is square root of x squared. It is absolute x, and its value could be negative or positive x, which results into these two horizontal asymptotes. I hope you enjoyed this journey of the review on limits, and in the process you also learn Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Keep sharing. Thank you and all the best.